Now I'm going to talk about parallel and perpendicular lines, okay? Now, parallel lines never meet. You know that. Parallel lines are something like this. These lines right here. Parallel lines never meet. Well, think about this. If my husband and I both start driving from our house on a 2-lane highway, going the same place, going the same direction, going the same speed, what's going to happen to us? We are going to drive exactly the same speed, exactly the same everything. Won't we just travel next to each other the entire time? Travel next to each other until we both get to our destination at the exact same time, yes? Traveling together, next to each other, next to each other. There's our destination. We never ran into each other. Nobody got there first. They're parallel. They're the same speed. All we're going to do is make somebody mad who wants to pass us because we're in that driving lane blocking everybody. Parallel lines have the same slope because they're going the same speed and they can't run into each other. Period. Parallel lines have the same slope. Parallel line slopes are equal. I mean, just think about it. It's intuitive. It makes sense. Okay, let me just jot a quick graph. Y equals 2x plus 1 and y equals 2x minus 3. Okay, our y-intercept is 1. Our slope is 2. That's up 2 over 1. Up 2 over 1. Up 2 over 1. Jot my line. Okay, now I'm going to do this one, but I'm going to start at -3. That's my y-intercept. I'm going to go up 2 over 1. Up 2 over 1. And since I'm traveling at the exact same speed, I didn't draw very straight, but you know what I mean. Since I'm traveling at the exact same speed, those lines are never going to meet because my speed is 2. Goes up 2 over 1 every time. That's like my speed, like 60 miles an hour. I could turn this into a real life word problem and call that 60 miles an hour. And we left we started at different starting places, but we're still traveling along the same road, going the same speed. Okay? All right. Now, perpendicular. Let's think about what we know about perpendicular. We've got one line going whatever speed we want. Then the other line has to be going, if this one's going in a positive direction, in order for something to be perpendicular to it, it has to be going in negative. Just think about why that makes sense. If one's going up, the other one has to be going down. In order for them to be perpendicular, which is meeting at a 90-degree angle, they have to be opposite directions. Okay, so they have to have opposite slopes. I think that is sort of intuitive. It makes sense that one has to go up, one has to go down in order for them to meet. Now, what that slope is a little more complicated. I'm just going to tell you and then prove it, but I'm not going to tell you why, because it's kind of beyond this course. But they also have to have reciprocals. Okay, they have to be opposites and they have to be reciprocals. So now you have to know what reciprocal means. Well, reciprocal means a fraction turned upside down, like when you used to have to multiply by the reciprocal in order to divide fractions. You took your fraction of 1/3 and you turned it over and made it 3 over 1, which was 3. Let's say I have this slope here and this slope going up is a +2. Then this slope going down will have to be a -1/2. Those are opposites and reciprocals. Another pair, I'll show you why in a minute. If I had a slope of 1/5, perpendicular would be -5. And this is a little symbol we use for perpendicular. Just make sure the signs are opposite, and then 1/5 flips over to 5/1. We don't need the over 1, that's invisible, but it's still there. 2/3 would be perpendicular to -3/2. 2/3 would be parallel to 2/3. -7/3 fifths would be perpendicular to 5/7, and negative 7/5 would be parallel to negative 7/5. Okay? Basically, this is kind of what it all comes down to. Perpendicular, opposite reciprocal, parallel, the same. Now let me just plot one of those to show you. Let's just do an easy one like 2 and negative 1/2. So let me say I have y equals 2x minus 1 and y equals negative 1/2 x plus 6. Now notice that the y-intercepts don't have to be the same, but they could be the same. I'll show you that it doesn't matter by doing one where they're different and one where they're the same. Okay, let's do y equals 2x minus 1. I go to negative 1 on the y-intercept. I mean negative 1 on the y-axis. My slope is 2 over 1. That's up 2 over 1. Up 2 over 1, up 2 over 1. Again, this graph is not perfect because I didn't use a graph board. Now I'm going to do up 6. That's my y-intercept. 2, 3, 4, 5, 6. Then I'm going to do down 1 over 2 because it's negative. So down 1 over 2. Down 1 over 2. Graph my line. I can see it meets at a right angle right here. They meet at a right angle. Now, it's not perfect. Don't get out a protractor and measure it because I just do it freehand. But if I was on a real graph board, this would be a perfect right angle right here. Okay, now let's do one where they meet at where they have the same y-intercept. Let's just say that I know 1/3 is perpendicular to negative 3. So I'm going to do y equals 1/3 x plus 2 and y equals negative 3x plus 2. I'm going to do the same y-intercept this time, so they're both crossing at positive 2. All right, positive 2. Then I go up 1 over 3 for the first one. Or I could go down 1 over 3 in the other direction. That's always a possibility, especially if you're running off the graph. Started at 2, up 1 over 3, or down 1, left 3. Then I go start at 2 again and go down 3 over 1 this time. Start at 2, go down 3 over 1, or up 3 over 1. Draw my graph. There you go. Again, you can see that they are perpendicular. But if I graphed y equals 1/3 x plus or minus 2, let's say 1/3 x minus 2, start at negative 2, go up 1 over 3, up 1 over 3 again. I graph that, and now I can see I have one parallel because those both had a slope of 1/3. This had a slope of 1/3. This had a slope of negative 3. Parallel lines, same slope. Perpendicular lines, opposite and reciprocal. There you go.